Wait, saan naman tawin? Sige. Sa, ano naman yung charge? Oh, ibat na pag-shoot. Pwede, tanggalon sa ako daw ibalhin direct. Sige, anak lang, anak lang. The last time, din anak ito na ito makadari. Ano yung siyang nilagakot na makadari? Charge. Let's charge. Charge ko nga. Napagapagida ako. Pressure sa lap. Ano format diha? The same ra ba ito format sa bago kasi na format ang descent video yan. Ang say nawa lang. Mauray nawa. The same lagi hapon na siya sa entry diha. Eh, marang maglubat ulit niya eh. Okay, which slide po tayo, class? Here, no? We're done in this slide. Dito. Na-discuss na natin to, two types of error.
Ma'am.
Ito, wala pa. This one.
Mana dahil ma'am, mana.
Mana, no, right? Okay. So, here, no? The different tests for a single mean. Okay, so let me continue with our discussion on hypothesis testing. Okay, for hypothesis testing on a single mean, there are two tests. We have the z-test and the t-tests. Okay, thank you, Rina. So when do we use this z-test? When do we use this t-test? So there is one thing that you should recall in deciding know which tests uh, you should use. So for z-test, whenever this sigma, this one, the population standard deviation, whenever it is known in the problem, you have to use z-test. If it is unknown, then you have to use t-tests. Okay, so this is the formula. Z equals to x bar, that's the sample mean, minus mu. Take note, this mu, the population mean, that is the value of your null hypothesis. So we call it the hypothesized value of the mean. Okay, so since this sigma is known, so you have there all over sigma divided by square root of n. So this is the formula for z-test. Okay, so for critical value, for a two-tailed test for the mean, where sigma is known, okay, to solve or to test the hypothesis using z-test, the first is you have to convert your sample statistic to your test statistic z. Okay, so this is actually following the central limit theorem, no? Where values are standardized using the z formula. Okay, and then we determine the critical value of z using the area of a normal curve. Yeah, I can now remember that I require you to have a copy of your Z table, right? Do you have with you your Z table? Charge ko ko ano yung last nasaksak na mo, no? Mauplit nito. Ilang baan. For a while pa sa kaya naglobat ko. Wala mo paong jud meron. Wala, uy, di unsa. Unsa ano nila ko. Eh. Sige sila may pilok mo. On man diha ang koan shell no? On diha ang saksakan. Naka-on ba? Yes, no. On pa sa pinabubang. Earlier. Ay, okay. Ay, salamat. Diyos ko. Okay. Siguro ano, naka-charge naman. Okay. Okay, so I want you to get your Z table. So this is the decision rule, no? This is the parang a situation when we can reject the null hypothesis and when we can not reject. So if the test statistic falls in the rejection region, we reject the null hypothesis. Otherwise, we cannot reject it. So say for example, we have this null hypothesis and the alternative. So say null hypothesis is mu equals to 3 against the alternative that mu is not equal to 3. Okay, so these two lines here, these are the critical values that divides the non-rejection region and the rejection region. So with this kind of um, symbol where we use not equal or unequal for alternative hypothesis, then we have a two-tailed test. Okay, but in the alternative, if we use greater than or less than, that's a one-tailed test. Okay, whenever we have a two-tailed test, we divide our level of significance alpha into two. Okay, that reflects on left and the right side of your rejection region. Okay, so this part here, this is the non-rejection region. Whenever your z-test fall in the non-rejection region, your decision is not to reject. If your z-tests falls within the rejection region, it's either pag two-tail siya, it's either less than on the negative value of your z, or it could be greater than on the positive value of your z. Okay, so these critical values are also called the cutoff values. Okay, so again, that defines the region of non-rejection and the region of rejection. Um, this part here, this is the lower critical value because you will compare your critical value to your negative z tests, no? And this one is the upper critical value because you are going to compare it with the positive z tests or the positive value of your z. So this is now the steps in testing the hypothesis. So first you have to establish or you have to state your null and the alternative hypothesis. So if you have already your null, it's either you use the symbol unequal, greater than, or less than for your alternative. Okay, you don't need to enumerate the three possible alternative hypotheses. So when you use unequal or the not equal, just use not equal. If it is less than, so isang alternative hypothesis lang for every null hypothesis. Okay, so for your level of significance, it's either the researcher choose the level of significance or it is set in the problem. Okay, and then the sample size end. So your second step after stating the hypothesis, the null and the alternative hypothesis, you have to choose your alpha. Okay, and then identify the sample size. N is given in the problem, so you have to identify the sample size in the problem. And then determine the appropriate test statistic. So this part here, if it is a test on a single mean, you just have to choose whether it's a z-test or a t-test. Okay? It is called test statistic without s when we are referring to a tool. Okay? And then determine the critical values. So the fourth step is you have to determine the critical values that divide the rejection and the non-rejection region. So where we can find the critical values, it depends on your statistical tests or test statistic. So if you are using a z-test, the critical value can be viewed at the z-table. If you are using the t-test for your problem, the critical values are found in the t-table values of your t. Okay, those are predetermined values of t. Okay, and then the fifth is collect the data and compute the value of the test. Meaning, you have to determine the data given in the problem. Okay, and then calculate. So if it is a z-test, you use the formula. So if it is a z-test, you use the formula for z. If it is a t-test, you use the formula for t. Okay, And then the last step is to make statistical decision. Decision refers to whether you have to reject the null hypothesis or you do not reject the null hypothesis because of insufficient data. Okay, and then you state the managerial conclusion. Um, the statement of the conclusion depends on what is asked in the problem. Okay, and then if the test statistic falls into the non-rejection region, do not reject the null hypothesis. If it falls into the rejection region, you reject the null hypothesis. So again, the conclusion must answer your problem, no? So you have to answer what is asked in the problem. Okay, that's how you state your conclusion. So we have here an example. We test the claim that the true mean number of TV sets in US homes is equal to 3. So there is a given assumption. We assume that sigma equals to zero point 0.8. Okay, so the first step is to um, write your hypothesis, the alternative and the null hypothesis. So in this example, we have here mu equals to 3 against the alternative that mu is not equal to 3. So this is not equal, therefore it is a two-tailed test or two-tailed tests. So given alpha equals to 0.05 and n equals to 100, we determine its z. Okay? Take note, it's a z-test because sigma, this one, the population standard deviation is known. Okay? So where can we find this plus and minus 1.96? Okay, basically it's in the z table. Let's see ha. Let me share with you a okay, let me share with you a Jamboard. Okay, let me share to you a Z table. Okay, is the table visible on your screen? Yes or no?
Yes, ma'am.
Okay, thank you. So, ano na ba yung ano natin? Um, we are looking for the critical value for alpha equals to 0.05. Lang ha. Okay, I will share na lang my entire screen para mas madali. Okay, take note na um our alpha is 0.05. Let's see. So let's have alpha is 0.05. Okay, so therefore, um, the confidence level is 0.95, or the confidence coefficient is 95%. So, or we have, is the whiteboard visible on your screen? Yes or
Yes.
no?
Yes, ma'am.
Okay. So this is
Yes.
our level of significance, 0.05, and our confidence level is 0.95. Okay. And we have a z-tests. Okay. And we have a two-tail tests. Okay. Take note, we have a two-tail test. So if we have a two-tail test, we have to divide our alpha with 2. And we consider two critical values, left and right. So let me shade the area of the rejection region. This one, this is the area of rejection region. Take note that alpha over 2 is, what is the value of alpha over 2? That's 0.05 divided by 2. That is equivalent to what? That is equivalent to what? Point. That is point.
Zero
Zero
twenty
twenty
five.
Okay.
five.
So that is 0.025. Okay. Take note, this is, that area is 0.025. Okay. This area is 0.025. And this area is 0.95. We are actually looking for the negative z sub 1 and the negative z sub 2. Okay. So we go to our z table. Okay. So this is the z table. So yung given natin is yung 0.95. So we look at the 0.95. Okay. So 0.95. So we have here 0.9554. This is 0.94. It's 0.9495. This is um 9505. Okay. So the 0.9495 and 0.9505, yung the exact middle value of these two probabilities is 0.9500. Do you agree? Do you agree, class, that the exact middle value of this is 0.9500?
Yes.
Okay. So what is the value of the z for 0.95? That is 1.16. Let's look at the above value. Take note, ito yun ha. This in between ito. So, tingnan natin. This one. This is zero point zero 0.04 and then 0.05. So, it's either 1.64 or 1.65. So, what do you think would be the middle? It's either 1.64. Actually, there is a process, we call it the interpolation. But since exact naman yung ano niya, middle value naman talaga siya. So what do you think would be the middle value for 1.64 and 1.65? That's 1 point. You can calculate the exact value no through interpolation. Okay, can you get the middle value of the this two? That's 1 point. 0.645, right? Let us go back to our problem. Okay, this is 0.05, so this is not supposedly 1.96, no? So this is 0.05. Unless, what is our, unless this is not a two-tailed test. So this is a two-tailed test. So let's see. So what will be our critical values? That's 1 point. Okay, so what should be the okay, take note this is 0.05. Okay, and the alternative is two-tailed test. So whenever we have a two-tailed test, let's go back here. When we have a two-tailed test, we divide our alpha with 2. Okay, that reflects both sides, the left and the right rejection region. Okay, so since this is a two-tailed test, the critical values must be 1 point. Okay, take note that we are using the Z table, no, to look for the critical value since our statistic is Z tests. So the 0.95 is exactly in between 1.64 and 1.65, right? So that one. This is 0.04, 0.05, and this is 1.6, so that's 1.64 and 1.65. Okay. Okay. So what is this 1.645? That's actually the critical value. Okay. Oh, so let us, okay, this is 0.025. So if this is 0.025, this must be, okay, um, point 0 or 0.45 rather. 0.475. Okay. So, teka lang ha, this is 0.025, this is 0.475. Tingnan natin yung left side din. This is 0.475. Okay, tingnan natin yung 0.475. This is 0.475. 475. So we have here 0.4602, 0.42. Sana yung 0.475. Saan siya mas close? Closer to yung 0.475 class. Closer to 0.4761 or closer to 0.4721? Hello? Are we using the same Z table? Yes or no?
Yes, ma'am.
Okay, we're using the same table. So, what will be our positive Z sub 2 here? What do you think would be the value? Okay, dito ako ha. I will draw another normal curve. Okay. I'll try to have I'll try to have one tail test. Okay, let's say this is a one tail test. Okay, this is the area of rejection. And then let's say I'll be using 0.01 as level of significance. Okay. I will ask you, what do you think is the Z alpha here? This is zero point zero 0.01. What is the Z alpha? Okay. Would like to answer. Okay, another, I'll give it one ha. I will number it um, number one. Second number two, I'll have another situation. So another normal curve. And then I will have a lower tail tests. Okay, this is the rejection region. Okay, and then my alpha is, I will have an alpha of 0.05. But that is a one tail test. Okay, so what do you think would be the critical value? Okay, pag nasa left siya, automatic we have a negative Z alpha. This Z alpha, that is your critical value. Okay, let's go back to number one. What do you think would be the critical value for Z alpha here? You use your Z table. Okay, let me share this one. Okay, I would like to answer. So we have two situation ha. Okay, this one, the first situation is we have an upper tail test and the alpha given is zero point zero 0.01. Second situation is we have a lower tail test but the alpha given is zero point zero 0.05. I want you to look for its critical value. Okay? Because the crucial part is the determination of its critical value. Kasi pag ma-determine mo na si critical value and you will calculate your Z tests, you will compare the calculated Z test with your Z alpha, with your critical value. In that calculated Z test, if it falls here in the rejection region, meaning that value is greater than the critical Z alpha. Okay, so the crucial part is the critical value, the determination of critical value. So let's practice. Okay, so while you are solving for its critical value, let me check your attendance. Okay, you say present if you are here in our meeting. Anthony Arambala, present. Absent. Ayonso Rogelio.
Ma'am, present ma'am.
Okay, present. Rogelio, present. Absent. Christian Ray Katamura.
Present ma'am.
Okay. Cleobeth Costanilla.
Present ma'am.
Jessie Kuna.
Present ma'am.
Manuel Dacal.
Present ma'am, present.
Nino Dalag.
Present ma'am, present.
Rizel De Chus. Rizel.
Present ma'am. Present.
Jamil Dizon. Dizon absent. Gideon.
Ma'am, na ma'am. Present.
Wendell. Wendell absent. Edgemar Maluluyon.
Present ma'am. Present ma'am.
Emmanuel Nogas. Nogas. Absent. Jomar Sales. Arjun Torilias. Joanne Beltran. Alona Culieta.
Present, ma'am. Present, ma'am.
Sinong Beltran present. Culieta present. Christine May Godinez.
Present, ma'am.
Baby Joy Gutierrez.
Present ma'am.
Christy Mendoza. Mendoza. Okay. Present. Rina
Present,
Ondigo.
ma'am. Present, ma'am.
Cassandra Ojero.
Present, ma'am. Present.
Janine Stefan. Baby Lynn Piamonte.
Present, ma'am. Present, ma'am.
Emerly Rosas.
Present, ma'am. Present, Rosas, ma'am.
Okay. Sino pa? Jezabel.
Present, ma'am. Present.
Emerly Rosas.
Present, ma'am.
Josefe Villanueva.
Present, ma'am.
Okay. Sino yung hindi natawag? Okay. What is now the answer to number 1 and number 2? Volunteer?
Try.
Yes. Okay, Rina.
Ma'am, ang akong
Yes.
answer ka, 0.18, 0.8159.
Taka lang ha. I-record ko lang yung participation mo. Okay. Your answer is point.
0.8159.
Taka lang. 0.8. Taka. Dito ko ilalagay to. 0.8. 159.
Yes, ma'am.
Okay, tingnan natin. So this is 0.01. If this is 0.01, this is 0.99. So titingnan natin dun sa Z table yung 0.99. Okay. So I will share the Z table ha. So si 0.99. Tingnan natin si 0.99. This is 0.9893. Okay. So 0.99 is closer to 0.9901. So this is 2.3. This is 0.9901. This is 2.3 plus 0.03. So that's 2.33. Therefore, the Z is 2.33. Okay. You will not look at the values inside the Z table because those are probabilities. Okay. And the given inside this normal curve, these are the probabilities. Okay. So yung titingnan mo is yung column and row or column and row values. So that's 0.33. Okay. So the critical value is the critical value is 2.33. Positive kasi it's on the one tail test is on the right side. What about the second situation? Would like to try. Okay, balik tayo doon sa ito pala, hindi pala nakita yung whiteboard. Okay, so this one. This is 2.33. Okay, this is 2.33. Okay, yung values inside the normal curve, those are probabilities. Yung values sa Z table, yung inside values sa Z table, those are probabilities. Yung critical value na titingnan natin, yung side values niya, yung column values, at saka yung row value or values. Okay? So, yung column value ng 0.99 is 2.3. Tapos, yung row value is 0.03. Right? That's 0.03. So, basically, that's 2.33. Okay? Okay. What about number 2? The second situation. Would like to try. What do you think could be the critical value? Left lower tail. So it's negative value of Z. Would like to try. Okay, may 5 points for those who will participate. What about Emerly? What do you think would be the critical value? Jezabel.
Nagkuhan pa ko mama ko panggit tanaw.
Okay. What about Piamonte? Cassandra? Rosas. Okay, sige, si Rosas. Emily.
Pakuan, ma'am.
Gutierrez. Beltran. Ubos ko na ata yung names ha. Julieta. Julieta.
Wala na ako nakasunod.
What about Edgemar? Edgemar. Okay. So, sige, tingnan natin sa Z-table, no? Take note that yung given natin, the second situation is 0.05. Pero, lower tail test siya. So 0.05, it's 0.95 on the non-rejection region. That's actually, kinumpute na natin siya kanina, di ba? It's 1 point. So it's in between 1.64 and 1.65. So the exact value ng 1.64 and 1.65 is 1.645. So therefore, si value natin is, since it is a lower tail tests, the Z critical value is negative. So that's negative 1.645. Okay? So, if you ask, ma'am, positive naman yung critical value na 1.645. Okay, yeah, it's positive, but we are looking at the lower tail tests. So, we negate the critical value. So, instead of 1.645, we get the negative value of our Z because of the alternative that is a lower tail test. Okay. So, I hope you will practice on how you determine the critical values in the Z table, no? Okay, so we will continue on our discussion on the example. Tapos, we already know how to determine the critical values. Next is how to make decision. So whether we reject or we do not reject the null hypothesis. So in that case, the crucial part is the determination of the critical value. Madali na lang yung pag-decide when you already have your critical value. Okay. So I would like to stop here. Any questions asked before we end the class? Questions?
Wala na, ma'am.
Okay.
Wala na, ma'am.
Thank you for your attendance this morning. I hope you practice on how to determine critical values. Bye. Thank you.